Okay, so here we are going to practice using Kirchhoff's voltage law, which basically says over any closed circuit, the sum of all the voltage rises, so the sum of all the voltage rises should equal the sum of all the voltage drops. But we're going to take advantage of it in the sense that we're going to add up all the rises and subtract off all the drops, and that should equal 0. That's just easier to do it that way. So we're going to pick any closed circuit. So you could pick one like this, shoop, and shoop, and shoop. And say we're going to start here, okay? So basically what's going to happen is we're going to follow along, and we're going to say start at our little starting point, which makes perfect sense, and we're going to go do, 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 do. Okay, so the first thing we run into is this VZ, okay? Now, if we go across VZ, we go from positive to negative, okay? So we always use the sign of the thing we land on. So since we landed on a negative sign, that means that we're going to write negative, and then we're going to write VZ, okay? This will make more sense the more we do it. So we'll go do, 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 do. Oops, okay. Now we have another voltage thingy that happens. This voltage is Vx, and it happens to be, as we hop over, we land on a voltage rise, voltage increase. So we write a plus sign, and we write our little Vx, Vx. And then we keep going on our trip. Do-doop, 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 oops, do-doop. Hey, you're not duping with me. Let's try again. Do-doop, 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 do-doop. Okay, here we go. We have negative 2V, and we land on a plus. So we're actually going to write plus, because of where we land on is a plus, but then the minus 2V, so we write minus 2. And go back on our trip, and do 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 do. We ended up where we started, so we're all done. So we're going to make that equal to 0. So what we really have now from this little loopy thing that we have is minus VZ. Let me write it where you'll be able to see it. Minus VZ plus Vx minus 2 is equal to 0. Now, there's not a whole lot we can do with that right now because we have 2 variables and only 1 equation, but that's okay. And so that just means we have to pick another loop and hope that it turns out a little bit better. So we'll pick another one. We got our beautiful little, what's it called, circuit thingy here. So let's start here. And we'll make our way around. Let's just pick this one. And this is actually going to probably be better because we can see just going along it, we've got a constant, a variable, and a constant. So we should actually be in better shape. So what we're going to do, again, start at the starting point and go do, 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 do. And so we see we have a negative 2 volts, and we land on a minus sign. Now, the last time we went down this particular path, we were going the other direction. Remember, we were going this way. But we're not going that way this time, and that's why this is actually going to get joined with a negative sign. We don't really care what the sign is on the voltage. We just care the sign where we land. So we write the sign where we land, which is a minus sign. Now we just blindly write negative 2 there. We always want to make sure we include our negative sign so we don't do something silly. But then we keep going. Do-do-do-do-do-do-do-do-do. Okay, now we got our little Vy. And we land on a plus. So we write plus Vy. Good? Alrighty. So we continue to go on our journey. Do-do-do-do-do-do. We get to another voltage. And since we land on a negative sign, that means it's a voltage drop from this perspective. So we minus off that 1, and then we do back to the start point. That means we're all done, so we set it off equal to 0. So now we can simplify. Minus a negative 2 is plus 4 plus Vy. Wait, how did I do that? That was crazy. Minus a negative 2 would just be plus 2, and then plus Vy. Minus 1 is equal to 0. So that gives us 1 plus Vy is equal to 0, or Vy is equal to negative 1, and that's in volts. So that means that Vy is negative 1 volts. So that's pretty awesome. We are inordinately proud, and therefore move on to see if we can figure out what Vz and Vx are. Okay, so we know that Vy is, what did we call it? We called it negative 1V. Negative 1V. Okay, so now we just have to pick another circuit. any circuit that you want. As long as it's a closed circuit, we're happy. So let's go this way. And chickadoom, and chickadoom, and chickadoom. And we're going to start here in the corner because we lack imagination. So we'll start here in the corner. Ba-doo, ba-doo, ba-doo. And again, we see our nice little VZ. But whenever we pop over, we see that we land on a negative sign. So we stick a negative sign out front because it's a voltage drop. See, we got our minus 3V. But whenever we hop across, we actually land on a plus sign. So that means it's a voltage rise of -3, which sounds really funny, but as long as you don't think about it and just write it down, you can solve this problem. And then worry about understanding it later. So we keep going, and we've got +1 here. But when we jump across, we see it's actually a drop in voltage. So we have minus +1. And then we end up at the start, so we can set it equal to 0. So we got negative VZ minus 3 minus 1 is equal to 0. So negative VZ minus 4 is equal to 0. And therefore, most fabulously, we discover that VZ is equal to, that would be -4 volts. Okay, so everywhere we have VZ, we can now write -4 volts. VZ is now -4 volts. So that's good, because now we can use this information on what we found the first time. Over here, remember we had this? All right, so let's see if I can be super fancy. And I'm going to copy this, and I'm going to start, and I'm going to paste it, like over here. All right, so we have that equation from that from the very first one we did. And so we have VZ is -4 volts. So we can plug that in. We have, let's see, we have minus, VZ is -4. So we actually have minus a -4 plus Vx minus 2 is 0. So that ends up with +4 plus Vx minus 2 is 0. So Vx, what is that? Plus 2 is 0. So that means that Vx is -2 volts. Okay, so now we actually have a value for Vx and for Vy and for Vz. So we can actually check this by picking one of the circuits that we didn't use and just make sure that the numbers work, because if they work for half of them, they should work for all of them. So we're going to go ahead and plug them back into our equation and make sure they all work. So we have Vx was, we said -2 volts, I think. Yeah, Vx was -2 volts. And Vz was -4 volts. Vz was -4 volts. And we had Vy was -1. -1 volt. Okay, so the only one that we have on here, well, not the only one we're going to care about that we have on here that we didn't use was this one. There's lots of others if you really want to get all freaky, but this one will be good enough to show. The point is, any one that you pick, these numbers should work out. So as long as we did it right, it should come good. And this is actually good because all three of our variables are on this equation, or on this circuit. So we're going to start, remember, at our little start point. Start. And we go across. And here's our -4. But when we hop across, we see that it is a drop. So we have a minus and -4. We continue along our little circuit, and we jump across, and we see we have a rise of -2. And then we continue along, and we see we have a rise of -1. And then we continue along here, we see we have a drop of +1. So we have a drop of +1. And then we're back to our start. So that's going to equal 0. So we hope that equals 0. Crossing our fingers, we've got minus and -4 is 4. -2, -1, -1, is that going to equal 0? Well, holy cow, it sure seems to. 0 equals 0, so that's good. We are inordinately happy now because that means we probably did everything right. But any closed circuit that you pick, these equations have to stay. But it's just a good idea just to pick one more random circuit and make sure that all your numbers work out. So now we can have a party.